And they like me, and I feed them kibbles and bits. That's why do you think we have different strains of dogs? They're genetically modified. So they have nice hips, nice coats. Where do dogs come from?
Wolves.
Wolves. How come we don't have wolves as pets?
They're too aggressive.
What? Because they eat it. So what they did through
They're
breeding, they genetically modified the wolf to make it domesticated.
So how did they like first initially genetically modified? What actually going and probably DNA?
No.
They said, this wolf doesn't seem to have a whole lot of aggression. This wolf doesn't have a whole lot of aggression. So let's make them. And then down through, we basically, through genetically modifying them, through selectivity, we've made it so they wag their tail
So we
and
can
not
get
just,
from a wolf to like chihuahuas.
yep,
That's just weird how it, just from modified wolves to this.
Yep. We have genetically modified E. coli. We have taken E. coli, which is in the normal environment, and we have incorporated into it human genes. So now the thing can make insulin. So every time a diabetic injects insulin into their body, because they would not have gotten past their first 10 years of life, it's from a genetically modified organism. That's why it's called Humulin. We didn't get it from a Humulin. We got it from an E. coli, which has genetic human genes. There we go. And they can't dispute that. Well, that's different, okay. More. Bunch of kooks.
I can't sit up all the time. I feel like I'm forgetting.
So I ridicule.
I have to have my feet on the
They
floor.
have no
I
defense
can't-
against the ridicule. That's the
I
beauty
can't
of
go to the
ridicule.
bar and
You
sit
have
on
no
bar
defense.
stools. I have to sit on a table. Can't.
So
It's
it's
like a
like
damn little kid.
So, I mean, what do you?
Give me,
believe?
what's a GMO? Give me an
I mean, I
example.
think of processed foods, but
Candy's processed, there's no DNA in it.
There's some processed vegetables. Braca flour. Broccoli and cauliflower mixed together. I mean,
What's
really.
gonna happen, you're gonna put that through your digestive tract, and it's gonna take those chemicals in there and break them up. So even if it's the DNA, you get DNA in meat, we break it down to the nucleic acids, and then we reassemble them in our body.
I'm sorry. I'm sorry, my
I
brain.
don't have enough to onion.
Okay.
That beat's gonna be stuck in my head all day now. I'm gonna be up on that damn stage doing some Zumba. I'm gonna be flopping on my
So-
face because I'm gonna be thinking of that.
Yeah, but Monsanto and DuPont, okay. Then don't eat it.
You know how many other foods that they make besides the ones that their actually names are on? That's the crazy thing.
What they don't tell you, you mean?
Not all the time.
Yeah.
Do you know how much a little thing of strawberries would cost? They didn't make it so those strawberries were disease resistant. You wouldn't buy them because they would probably be $300-400 for a little box of strawberries. Because you can only eat the ones that live. We've genetically modified the cows. We've made it so they're so heavy full of beef and meat that they can't mate.
But there's so many like organic, non-GMO plants and foods you can buy.
Well, there weren't GMOs and everybody ate organic stuff back in, the 1800s, but what was their life expectancy?
Okay, but I think in this time period, if I
Like
were to eat-
35.
If I were to only eat non-GMO
You people be
foods,
on Social Security.
Probably still be just as good off nowadays is, I mean, back in the 1800s, as you say, a lot of people died, but there's a lot of other reasons, a lot of other factors.
Yeah, well, the big one was they got sick because their immune systems are crap because they couldn't nutritionally feed it. They got infections or trauma, which then they didn't heal very well from. So the people who are on the GMO, anti-GMO, and there might be someone in here who think you can say that because the environment is such that, okay, if I don't eat these things, these GMOs, there's still other options. So I can still spew off my meaningless babble, but I'll still survive. And I probably got a vaccine somewhere from because it was made from a genetically modified organism, which is protecting me, but that's different. I like me, and I don't want to get chlamydia.
You should have been an attorney. I think you should have been an attorney. Forget being a doctor.
Why?
Because you probably can come up with an argument against what everybody says.
And I can lie. I'm good at that. When my mother said, "Look at me," I would look her right in the eye, and I would be lying right to her. That's what I'm trying to train my kids to do.
Oh, jeez.
Learn how to
To
lie.
lie. I just assume they already are. But their mother pulls off that, "Look at me!" Look at me like you can tell. Get the, because I lied to you, you couldn't tell. So how you do it, that's the hook. If you're brutally honest most of the time, does this make me look heavy? I wouldn't get on a scale. They're not gonna like that 4-digit number.
Oh hell. Did you say that? Yeah. Oh my God, I would have
I was trying to get you well enough not to even ask you that. We hadn't met you that long, and I don't think I'd ask you about a pen.
I said, "Oh my God, you got more rolls than a baker." Who made you those pants? NASA?
Oh.
Am I gonna have to buy 2 plane tickets for you?
4.
Exactly.
I could talk some shit about my ex too, so you know.
So when it came time to, did you do that? No. Why would I, have I lied to you up to this point? No. You have to set the foundation for things later on.
It's peeling.
So if you do that now, when the time comes and you
Mine
have
is
to
too.
use that, you've already got the foundation.
It is. I can't wait for this one.
We're gonna get time to. I fell asleep. Or we just looking
Time, you want like
This one I was
the herb.
I was on my stomach and I didn't move for an hour and a half.
Really?
I was too afraid to
classes,
move.
we have to do it all.
My arm was hanging
Most
on
of
the
it's gonna be
table,
outside.
and I fell asleep.
Well, I'll give you some time next
I
week.
guess she actually stopped in the middle. She's snoring.
No, it was like, he did it like 20 minutes less.
Yeah.
All right.
Then
When
he
is,
started going harder because he wanted it darker.
Have you seen my back?
do you know when the last practical will be?
It's gonna last me.
What day is that?
I want a big one.
I
I want
don't know what the day is.
I
What
had
is it?
a-
For us,
I
it would
wanted
be
to cover the entry one and the exit
April,
one, so I wanted to like wrap around my leg.
something like that.
I
2
don't know.
weeks.
I'm gonna I build up my tolerance.
2 weeks.
Do Black Panther.
28?
You will have a quiz.
Coming up your leg with a tail.
2 weeks, yeah.
Like it could look like
On
it's
everything
wrapping
we've been
around your
doing.
leg.
I
Yeah,
mean, this last
everything.
couple
Charge me
weeks.
for that.
I don't mean before the last practical.
Like I
The
only,
last
she
practical
only
was
charged me
now.
130 for my
No,
arm
it's
back.
quiz.
I gave her 2.
And then we're gonna present our case notes.
She's really
What you're
good.
saying?
Yes.
They probably
Quiz
charge
will
me for
just
something
cover
like that.
respiratory and the stuff I'm going over on urinary.
Depends on the detail too. And then shading, it's just gonna take.
And then after the quiz, we'll do our silly little group project. We'll have the fellowship.
So your quiz isn't gonna be worth 100 points?
What do you mean?
Well, because our tests are 25 questions, and they're like, what, 4 points each, equaling 100?
Well, this will be something like that.
So it's a test, correct?
Yes,
Okay.
but it's a
Same point.
quiz, which is a
What's the
bunch of
difference?
questions,
I don't think
as
there's a
opposed to a
difference
practical where you have to then do hands-on stuff.
Okay, that makes sense.
All right. So about the same amount of questions then?
Yeah, 20, 25 questions.
Because that can be good or bad, because if you don't do good, and the questions are worth so much, if you do good, it's to your benefit, but if you don't, then, you miss.
But isn't everything in life that way? It's called the double-edged sword.
No, and I don't even know if this is over.
Marriage is good, but then it could be bad. One was good, no. Bad.
I am divorced.
All right.
They like oversee the.
So I guess we're doing urinary.
machines and all that monitors.
It looks like.
Yeah. I was looking at it.
That beat, can't hear it.
I don't think so.
I didn't hear it.
I see a green light though.
There's some orange flashing thing on the back.
I haven't heard of the average salary of like 93,000
It's off now.
Growth.
per feet.
There it goes.
I never even heard of it.
What?
I wonder how much education there is.
Okay.
Or if anybody around from down here.
I think you have to have like that.
Oh yeah, it is almost done.
More than a master's. I don't know though.
All right, gang, what
Like
we want
how?
to do is go through the basic anatomy and some general functions related to the urinary system. And we have a silly thing here, artificial urine thing.
We're gonna do that or we're not gonna do that?
Well, I'm not doing this. Technically, you would be doing a urinalysis lab, which is basically, we got some artificial urine, you put in dipstick and say, pH is too low, has too much of this, too much of that. I don't, that's fine. The learning of that is actually minimal, and the rule is, usually the minimal the learning, the least important it is. So what we want to do is have a general overview of what I would expect to find in a typical normal urine sample, which would then set the stage for what I would see if there was an abnormal urine sample. Now, when we take a look at the urinary system, anatomically, it's not a very complex system. You have the kidneys, and these organs are hooked up to the bloodstream, so I'll count the renal artery and renal vein as part of this as well. So you have a couple of blood vessels, you then have the kidney, then you have a downspout from the kidney, that's called the ureter, which then attaches to a cistern, which is called the bladder. This is basically a holding tank. And then you have a tube that goes from the bladder out, and that's called the urethra. That's it. That is your basic overall anatomy, gross anatomy of the urinary system.
I have a quick question. Like when people get UTIs, like the bladder infections, how, when you don't really have to go and you still feel that pressure, why is that?
Because of the swelling in the bladder wall, it's hitting the nerve ending. So the nerve endings, because of the swelling, they're feeling pressure, and that's what they react to. Whether it's pressure from the bladder expanded or pressure from the swelling in the wall, they're just going to react.
And that's why it's painful.
Yeah. So depending on where the UTI is it lower or upper or whatever. Right? So anatomically, not a very complicated system. What makes the system challenging is because we can't see the working parts. When you take a look inside the kidney, that's where you start seeing the detail unfold. Most of the stuff, I mean, the ureter, it's just a tube. It's like a gutter. It just takes the fluid in a downward direction away from the kidney. The bladder, that's just a holding tank, so you're not leaking all the time. You reach a certain volume, and then you'll discharge that at a particular interval. And that's what the urethra is. It's just an outward tract to get it out of the body. When we start taking a look at the detailed anatomy within the kidney, you'll start to see these smaller and smaller pieces come into play. Eventually, what we're going to get down to are these structures here. These are nephrons. Nephrons are the basic structural and functional unit of the kidney. Each kidney is made up about 1 million of these things.
What is this view of though? I mean,
That's a microscopic view of the internal aspect of the kidney.
the actual kidney itself
Yeah,
inside?
so what we have done, I'll backtrack. Slice open the kidney. Basically what we go do.
Okay.
What I want to do is now start, with these pictures, start looking here. A lot of the stuff that we're seeing in here is formed by the collective gathering of all the nephrons inside the kidney. I now magnify a little bit further and I see this area highlighted. That's a couple of nephrons. I want to magnify that, and that's what I get. The nephron is the basic structural and functional unit of the kidney. When we talk about what the kidney does, this and that, basically we're saying this is what the nephron does. So when we take a look at the overall function of the urinary system, in essence what we're looking at is what the nephrons do. And their job is indispensable. Without the nephrons or a sufficient number of nephrons, you'll die relatively quickly. So if your nephrons stopped today, what's today, Tuesday? You probably wouldn't see Monday. You'd be hard pressed to see Sunday. Now you might be alive, but you're probably not going to be awake Thursday, Friday. You're going to be in a coma. Because what the nephrons do is everything they're centered around them is designed to maintain the physical and chemical properties of blood. Yep, the nephron's job is to maintain the physical and chemical properties of blood. Now, they can't do it alone. They have to work with other systems. But their job, you can't substitute with anyone else. So any of the actual job that I am going to list what the kidneys do or the nephrons do is going to be related to maintaining a physical or chemical property of blood. Physical and chemical. Because blood's a fluid, right? What's your internal environment?
Almost fluid.
Body fluids. What's the fluid that all your other fluids are derived from?
Blood.
Blood. Blood is your stock solution. So in order for the blood to be the foundation for all our other body fluids, we have to maintain the physical and chemical properties of blood. Because all fluids have two things: physical properties, chemical properties. Physical properties include things like volume, pH, viscosity, pressure, temperature, osmolarity. I love that word. I don't even know what that is, Dr. Black. What's osmosis? Water. So osmolarity is the amount of water and how much stuff is dissolved in it. That's a physical property. What?
Water.
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 Are you Midwestern? Water. Water.
Is that guy on dialysis?
Yeah. Here we have properties and composition of urine. Okay? I'm just using this for a list. So you'll see we have physical properties, specific gravity, osmolarity, pH. Those properties are directly attributed to blood. And then you can see the chemical makeup of a typical urine sample. Many of these chemicals it gets from the blood. So even though urine has its own physical and chemical properties, which are what are measured on a urine test, they're all derived from blood. Okay, blood is the stock solution. So what the nephron is trying to do is to maintain the normal physical makeup and chemical composition of the blood. So every time you drink water, that water is going to get into the blood. That would change your volume and your chemical makeup. So what the kidneys will do is get rid of the excess. So kidneys maintain the normal volume of blood. Have to pee. If you don't drink water, the kidneys are going to try and maintain the normal blood volume.
Do people have the same size bladder? Because some people have to go more often than others. I mean, they'll say, oh, you must have a small bladder. I mean, are there different sizes, or is it?
Yeah, you probably have different sizes. I mean, I don't know what the bladder imagery would be.
And if you're heavier, is it bigger? Or if you're thinner, is it smaller?
I would assume if you're heavier, it's not bigger, it just doesn't have as much room to expand.
Oh, because it's fat and not.
I think having kids mess my bladder up.
Is that, I wonder if that's true. She said if having kids mess up your bladder.
Sure.
What, just from the weight of the baby?
Pressure on it, yeah, it's going to
Pregnancy?
distort, it's going to change.
Pregnancy or delivery?
Pregnancy. Why do you think you have to go as much? Where do you think the uterus is relative to the bladder?
Behind it, right? I'll just talk to you.
Do I have it on here? Uterus would be here. It would be behind it. So when this thing fills up, it's going to start crushing. I have to go. Just when I have to go again.
Could there be like a fluctuation in like nerve activity in the bladder?
Yeah, there could be.
So 2 of my kids were over 10 pounds, so that
Or
means
mine.
they were really pushing it.
They're pushing it, yeah.
Oh, you had
Everything's got to displace and move to the side. So the kidneys help, or the nephrons help maintain blood volume. They are going to help maintain, because of blood volume, they're going to help maintain pressure. They're going to help maintain the osmolarity, so they're going to do that by being able to maintain water levels of the blood So we always have the right amount of stuff dissolved in. The kidneys release erythropoietin. What does that trigger production of?
Red blood cells.
Yeah, so we're maintaining normal composition of blood because the kidneys are involved in red blood cell production. The kidneys will help to maintain electrolyte levels of the blood. So if you decide, I don't know, between now and 3 o'clock you want to eat a whole bag of Wise potato chips, what's your salt level going to do?
Go up.
Go up. Your blood won't even know it hit it. Kidney will get rid of it, and your electrolyte levels will stay the same.
Or you'll get edema.
What?
Or you'll get some edema.
Under normal circumstances, you
Oh,
wouldn't.
normal.
You wouldn't. Kidneys will maintain pH. So any acids that accumulate in the blood, kidney will get rid of it. Kidneys are your main pH controlling organs. And I'll go over a little bit of acid-base balance next week. But the kidneys help to do that. So in essence, everything I'm listing right now, the kidneys are preventing from changing, either from preventing it from occurring or getting too much, an increase, or a decrease. Now, there will be times or instances where chemicals not normally found in the blood will find themselves in the blood. Kidney will help get rid of them. And in this case, it works in tandem with the liver.
So it gets rid of foreign objects in the blood?
Chemicals, I don't think it's going to get rid of, objects. So medications, those are foreign, kidney will get rid of them. If kidney can't, that medication can become toxic. So that's why people who are in renal failure, you have to kind of adjust and figure out what will the normal dose be. It's usually less than what it would be for someone whose kidneys are functioning. And this is where aging comes in. I said before that each kidney has about 1 million. So by the time you're up to speed running, you have about 2 million functioning nephrons. By the time you are 65, 70, you have lost 1/3 to 1/2 of your nephrons. So you've basically donated a kidney back to nature. So do you give geriatric individuals the same dose that you would give someone in their 20s? No, and that's one reason why. Because they can't get rid of the medication as quickly. So a large dose would mean too much would circulate in the bloodstream too long, and that can have side effects on the heart, the brain, or whatever. So you have geriatric doses, just like you have pediatric doses.
So the kidney and the liver gets rid of meds.
Generally, yeah, the liver will get rid of fat soluble, kidney will get rid of water soluble, as a rule.
What about kidney stones? How does that work? The formation of kidney stones and everything, and how it's...
Those are usually salts that have crystallized, and it's because of the solubility. So usually what changes that is the pH. So either the urine has become too acidic or too basic, and that causes certain crystals to harden.
So that's why they say, like, don't drink teas and stuff like
Right,
that.
because of the acidity. But they have to figure that out. So if you have kidney stones, basically you have to pee through a screen. If you get rid of the stone, you then have to bring that back to a lab, and they have to analyze it.
So even though tea is basically made with water, it's still too acidic to
Yeah.
drink all the time.
Right.
Because I drink
Or-
green tea all the
or-
time.
yeah,
So
but-
they say it's good for you, but at the same time, I guess it's not.
It's called the double-edged sword of
Yeah.
life.
But if you're not prone to kidney stones.
Yeah, and that's not a,
Does eating Tums make you more alkaline?
but you know how much you would have
I know, I like that. I like the Tums.
to eat that much. Well, it'll have more of an alkaline effect on your stomach than it would your blood,
Yeah.
because the blood's gonna start to neutralize it, so. And then by the time, as long as you're not massively overdosing the blood, that gives the kidneys time to get rid of it. So again, they're preventing an issue from occurring.
It also prevents digestions of like your red meats
Yeah.
because you're killing
Because
all that
you need the
acid.
acids to break down the proteins. And you need the acids to convert the iron in the meat
Mhm.
from F3 to F2, because that's the only type that we can use.
And people take
Very
Tums though
interesting.
for calcium, but if they're not getting a D supplement, then it's not even gonna affect them.
They're supposed to be taken, yeah, but
Because I have residents who get, the doctors prescribe the calcium all times a day,
it
and
doesn't
some
mean
of
they
them
know
don't have
how
a
they're
D.
doing.
No, not all the time.
Yeah, I have the R in front of my name, and that doesn't mean a damn thing. It gives you the impression, and then we let you conclude. But after an interaction, you figured it out.
Yeah.
My family doctor tells me I know more about nutrition than she does, so she doesn't have to worry about me.
Check it out. Right, you know it.
Now, one of the key features of the kidney, and this will kill you quicker than any of those other things that I mentioned if we let them go out of whack, is the fact that our body produces metabolic waste products. And for the most part, gang, this is how we get rid of those metabolic wastes. We will get rid of some through the liver. We will breathe some out. We'll sweat some out. But for the most part, we're getting rid of them through the kidney. So, removal of metabolic waste is absolutely crucial for survival and homeostasis. So that's where the kidney comes in. Because although some of the other systems might attempt to get rid of some, they can't get rid of the quantity that the kidneys can.
What's an example of metabolic waste?
I'm gonna go
Oh.
through that. The primary component of metabolic wastes that winds up being an issue is nitrogen. So if you take a look at these 4 metabolic wastes, the key component to these is nitrogen. So as a group, these are called the nitrogenous wastes. And these are manufactured by our cells and tissues. These waste products, you did not ingest these. Our cells made them. So what I want to go through in general is give you the metabolic waste, these 4 things here, and kind of give you an idea where they originate from. Which in certain cases will help to explain why you can't eat certain things and stuff like that with kidney problems. So the first one, and the simplest one of the nitrogenous wastes, is ammonia. Ammonia is NH3. What do I have? Chapter 2. This is why the kidney stuff is at the end, because you have to know a lot of stuff about the previous chapters to understand how the kidneys and stuff work. And since these are metabolic, what's the definition of metabolism? Chapter 1. Right, sum total of all chemical reactions in the body. So these metabolic wastes come from those chemical reactions. Well, those chemical reactions we went over in chapter 2, especially with the organic compounds. What are the 4 primary organic compounds? Don't you just love memory lane? Memory. Lipids. Protein. Not the
Amino acids.
old nucleic acids.
Nucleic
Acids. Get it? Old
amino acids? No.
carbohydrates. Now every one of
I'm
those,
screwed.
you have monomers and polymers. What are monomers?
Something with one.
Who?
Something with one.
Mers.
MERS. MERS with
That's
one.
a 1 mer, a 2 mer. A 2 mer. Got a million of them today. Yeah, those are the building blocks. So what were the building blocks of protein?
Amino acids.
Amino acids. What I drew here is the basic structural formula for all amino acids. 2 carbons. Off of the 1 carbon, I have a double bonded oxygen. There's oxygen and hydrogen here. This end of the molecule is the acid end. And then over here, I have, off of this carbon, I have a nitrogen, which they said, well, let's use the German word for nitrogen, and we'll call that
Amino.
amino. So if we put those 2 names together, what do we get? Amino acids. The X is what makes every amino acid different, the other chemical attached to it. But this is the framework that they all have. Every amino acid that we metabolize, every freaking one, our little psychotic friends. If we want to utilize this, we have to take the nitrogen off. The process when we remove the nitrogen is called deamination. Why would we remove it? Because we don't need it, we just need the 2 carbons. Or I can take that amino, the nitrogen group, and I can transfer it to another compound. And we have a group of enzymes that do that. They are called transaminases. Anyone ever hear of the transaminases? Acapella group. Oh my God.
And those do what?
They transfer the amino group to another compound. Now this is done primarily in the liver. So they're going to do a test and they're going to measure those transaminase levels. SGOT, SGPTs, the ALSTs, the ASTs. Those are quote unquote the liver enzymes. Those are the enzymes they test for liver function. So if you get liquored up too much, what's the doctor going to say? Your liver enzymes is a little high. Those are the transaminases.
What is the change?
They're enzymes. they transfer the amino group to other compounds. But the end result is we now have to deal with that nitrogen. In order to remove that amino group, either through the transamination process or the deamination, notice it's telling you what it's doing. In order to do that, the first thing I'm going to do is break the bond, and then I'm going to put a hydrogen to this. So instead of having NH2, I now form what?
H3?
NH3, which is ammonia. So the ammonia that our body makes comes directly from us using proteins. So this is why when people are in renal failure or liver failure, you have to give them low proteins.
Because if they would have more protein.
They're going to produce more ammonia. And when your ammonia levels go up, we can't measure that directly, but what we will do is we will measure what we derive from ammonia. So to neutralize ammonia, okay? To neutralize ammonia, hold on. Okay? What I'll do is take a carbon dioxide. I'll start with CO2. What I'll do is I'll knock off one of the oxygens, so I'll have one of the oxygens with a double bond, and then what I'll do is that I'll knock off one of the hydrogens. So I can neutralize two ammonia molecules with a carbon dioxide molecule. This compound is called urea. So I don't measure the amount of ammonia directly, I measure the amount of urea. So, and what I'm measuring is the amount of nitrogen with the urea. So that's a blood test that's called BUN. Blood, urea, nitrogen. Is that a common blood test?
Mm-hmm.
You betcha.
So when they ask, like, about your urine, like if it has a foul odor or anything like that, is that based off of the ammonia? Like what
It could be.
chemical
It
gives
could
that?
be.
But there's no one of these that actually gives it that
Urea will.
urea?
But I mean, it could be an infection.
Right.
Bacteria will. The ammonia is because of volatile. Volatile means a liquid that can very easily convert to a gas. So you don't smell water because it's not very volatile.
Okay. That makes
But
sense.
certain liquids, for example, rubbing alcohol, very volatile.
Right.
It can go from a liquid to a gas state very quickly, so you smell it.
So the more protein you eat, the higher your ammonia level,
Potentially.
the more.
But what happens is ammonia, gang, ammonia has a pH of about 12 to 13. That will kill you very quickly. So what we'll do is neutralize the liver, and here's where the liver comes in. The liver will convert the ammonia to urea, which has a pH of about 7.5, which is closer to our normal pH. So in other words, it's almost harmless. We'll get rid of this from the body. If we allow the nitrogen levels of the ammonia or the urea to increase, when you increase nitrogen in the blood, we call that azotemia. Increase in nitrogen levels in your blood is called azotemia. Gang, these words sound foreign, but they are probably used every day in a clinical setting, especially a hospital setting. You give someone a medication, you're going to be checking BUN levels. If the BUN levels go up in the blood, that means one of two things. You are either producing way too much or the kidneys aren't getting rid of it fast enough. Or both, I guess, so three things. So if the BUN is going up, they got to figure out why. So it could be because you're on a medication, so they have to lower the dose. Because the medication could be nephrotoxic. What does that mean?
Toxic to your kidneys.
Yeah, it's affecting the kidneys. It's slowing down the kidney's ability to get rid of the waste products. Many antibiotics are nephrotoxic. Does this make sense? So this is the origin of these two waste products, from our ability to metabolize protein. So if you have somebody that's in renal failure and you want to get rid of them quick, here, Grandma, have some protein, Grandma. I got the beef. You need the protein for the strength, Grandma. Hey, I'm giving you pearls here, and no one's writing it down.
Oh, because my grandparents are all dead.
Because at the hospital, they tell us to tell the kidney patients to eat protein. They push like eat.
Well, if they're on dialysis,
Are
they
they
can-
on dialysis? Yeah,
That's
okay,
why.
that's fine.
So that's why they push. They
Yeah, I'll give them high doses of a medication, but I'll time that with, and that's what I used to do. I used to time it with their dialysis. So if they had an infection, because they're usually on low protein diets, and their antibody levels are a little bit low and what have you, we'll give them high doses of antibiotics. So if it was around too long, it would cause a problem. But if they time it with the dialysis, which is usually every other day, you can give them a high dose, and then the dialysis machine will get rid of that, and then just do it again. So there's ways around it, but someone that's in renal failure where they're not on dialysis, they have to be on a low-protein diet, which is a catch-22 because you need that to build structural proteins and stuff like that. But to do that, we're always going to produce a waste product, and that is ammonia. And then you're going to produce urea. Now, most of the urea that we produce, we get rid of through the kidney. So this is why, what do they call those things with the new parents?
Babies.
You put the thing, what did you bring home?
Baby.
The baby. And that thing uses that diaper, goes through them like freaking water. Yeah, that thing, the anaconda.
The anaconda.
Who came up with this nonsense? Yeah, you keep the diaper around, and they just put it inside some type of freaking bag, and the thing sits there. It looks like an anaconda. They hold a family of raccoons. What does that thing smell like after a while? Ammonia. What does a locker room smell like after a while? Ammonia. And animals that have high protein diets, that's what their urine's going to smell like. Ammonia. Because the kidneys are getting rid of that waste product so they don't go into azotemia. If you allow azotemia to continue, azotemia will turn into the next stage, which is uremia. And uremia is basically where your blood has now converted to urine. So now your heart's pumping urine around the body. It's doing it now, but the amount of urine is so little in the blood, because the kidneys are getting rid of it, it's not harmful. If they find this interesting, take a biochemistry class.
Thanks.
What? Oh my God, it's cleansing the soul. A biochemistry class will. What?
That's a lot of math.
Oh, there's very little math in biochemistry. General chem, there's a lot of math. Biochemistry is all of these frickin' pathways. So when I had biochemistry, I had to know from protein. Here was one of the questions we had. Dr. Reinhardt. You are held up in a ghost town. It starts, this is the question. Okay, ghost town. So you are trapped in the back of a deserted saloon because the ghost town is inhabited by desperados and mean hombres. So we haven't even gotten to it yet, and he's painting his picture. And it was, basically you're going to have to be there a while. The only things you have to eat are a box of laundry detergent and a bearskin rug. Which are you going to eat and why? And whichever one you choose, you have to go through the biochemical pathways.
Oh my God.
Yeah. So which one would you eat? The
Bear.
rug?
Yeah.
I ain't eating bears.
I wouldn't eat the laundry
You took
soap
the hard
either.
road.
Because the bearskin rug is going to be mostly protein, the hair and the protein.
Right.
Yeah.
So to go through all of so I'm taking the box of detergent, which is fats. Soaps, fats, they're lipids. They're emulsifying agents. So beta oxidation has a lot less steps than going through the freaking liver and the kidney and everything.
Right on.
But you had to know that. And that was Dr. Reinhardt. This is a guy that would light up cigarettes right in the middle of class. And he would walk in like this. He'd have a folder. Any questions?
Sounds like him.
And he have a little ashtray up here. And he would never even look. We assumed those were lecture notes, but he wouldn't lecture. He would just walk back and forth. And as you can see, the nitrogen goes over to the beta, and the enzyme that does that.
Oh my God.
And then he would light up another cigarette.
You ever wonder what was in
I'm
that
assuming
folder?
he's dead.
No. What?
He said, I'm assuming he's dead.
This was a biochemist from the 60s. He was like, if you people want to know how to make LSD.
That's awesome.
He's probably smoking the wacky
Absolutely brilliant. Absolutely brilliant.
Yeah, because he was doing those mushrooms,
That's
probably.
awesome.
And we've had him. I had him for 4 hours a day. Lecture was 4 hours. Usually 2 hours, break, and then another 2 hours. And then during the breaks, usually after an hour, he'd let us out for 10 or 15 minutes. And then he'd be just lighting up again. Those were the days when you could smoke in class.
That's crazy.
Oh my God. And if you think that I'm a jackass, he would belittle you. Oh my God. When people would ask stupid questions, he wouldn't even acknowledge it. Dr. Reinhardt, if you ask me again. Oh my God, they would just cower.
Yeah.
And he'd light up another cigarette.
I'd be very, very quiet in that class.
What?
I said I would be very, very
Oh my
quiet
God,
in
yeah.
that class.
I was just waiting for people to ask questions to watch them berate them. All right, so the ammonia and the urea, they come from the breakdown of proteins. The next chemical, uric acid. This comes from Hamlet. Shakespeare, get it?
No.
Alas, poor Uric. I knew him well.
I never know.
Didn't you have to read Hamlet in that silly thing called high school?
No.
What did you have to read?
Nothing.
Romeo and Juliet.
What?
Yeah.
That was it?
Yeah.
Mouse and Men.
Yeah,
Mouse
there
and
you
Men. We read that.
Whittled it down quite a
Minute
bit when
Maid.
we were old.
Tale of Two Cities? That's John Steinbeck.
Yep.
A Brave New World, I think, too.
The Raven.
Oh, Animal Farm. I remember that one.
Charlotte's Web? If a fair is a smorgasbord, where a rat can feast. It's
Hunger Games.
I wish we got.
Oh, yeah, my kid liked it.
Shakespeare.
For me, I haven't watched
Hamlet holding up his friend's skull. Alas, poor Uric, I knew him
We did
well.
Hunger Games in high school.
Uric
It was
acid.
worth it for me.
Anybody know where that comes from? Anybody remember these rings?
I remember.
Peptides.
Peptides are proteins. Nope.
Are they organic?
Do they have carbon?
Yeah.
Yeah.
Amino acids?
Oranges.
Not amino acids, those are proteins.
Oh, right.
You're in the ballpark.
Oh,
Calcium?
new.
Uric acid. Can I erase this? You
Yes,
guys done?
please. What was that other thing you said?
Nope.
Nucleic acids?
I don't remember chemistry. I can't even remember yesterday half the time.
That's what I just said.
Nucleic acids. What are the building blocks, the monomers for nucleic acids? So, not phospholipid, that's a part of one of the building blocks. In the phosphate, but not the building.
Nucleotides.
Nucleotides. Nucleotides are the building blocks for nucleic acids. Who remembers the nucleotides?
The Prince of Tides.
Tide is
And I'm holding
Deborah
on.
Harry?
Oh, yeah, I used to like this song.
They were like a couple of towns over. That's where they were from me.
Oh, really?
Yeah, they were from Jersey, New York area.
Oh, wow.
You had adenine, guanine, cytosine, thymine,
These are all the.
and uracil.
This is all the uric acid.
Yes, well, not yet. Within that, we have, you can break those down into two groups. You have pyrimidines, which are single ring nucleotides. And then you have the purines, which are the double ring. One ring, two ring. And for you, it's three rings, because that's the suffer ring. It's like the three rings of relationships. Engagement ring, wedding ring, suffer ring. So uric acid comes from the DNA. When we break down DNA, because every time a cell dies, we have to take its nucleus and break down its DNA. So we can reuse it, but we have to reuse it by breaking it down first into the nucleotides. Some of them we're going to break down further, and when we break down the purines, we break it down into uric acid. If we do not get rid of this uric acid, it will crystallize in our joints, and now anybody know what that's called?
Gout.
Gout. So, do they give people with gout lots of red meat? No, because what's red meat?
Protein.
Not protein.
DNA.
Oh,
Where did the red meat come from?
A cow.
Cows. Well, how did that cow walk? What moved the bones?
Skeletal
Muscle. So the red meat is basically muscle tissue. Muscle cells are multinucleated. One muscle cell can, what?
It's just so much to try to figure out.
One muscle cell can have hundreds of nuclei. So the more red meat you eat, the more DNA you ingest, the more uric acid you're going to produce.
Is that why they tell you
That's
not
why
to
they
eat red
tell you
meat?
not to eat the red meat.
So why does your
Why
urine
don't they just
stink
say
when you
that?
eat an abundance of asparagus?
I'd say asparagus.
I don't know what the chemical makeup is of asparagus, but there's probably some chemical in there the kidney gets rid of. They'll do that with caffeine. We get rid of it through the kidney.
You're supposed to eat asparagus to make up for that? Is that what you're saying?
No,
It gives your.
It has a pungent.
some lab screwed up my urine test when I went for a drug test, so I ate an abundance of asparagus before I went in the second time. It stank. Assholes.
You're supposed to clear it out or something,
Yeah.
asparagus?
Yeah,
It has to
No,
do
it
that.
smells really
has to do
bad.
that. yeah.
Oh,
So we will
And I
produce
took
uric
extra
acid.
vitamin B, so it was like this color
Not
yellow.
nearly
and it
as
stank.
toxic as ammonia, but it's nothing to play around with. So we do blood tests again to measure uric acid levels. So we have medications that will assist the kidney in getting rid of these. Anyone ever hear of probenecid? That's what we call a uricosurety. Gets rid of the uric acid. So generally, when you have high uric acid levels, they got to check two things. Are you an overproducer? So are red cell or cells dying too quickly in your body, or are you an underexcreter? I've seen individuals who present with leukemia and their presenting symptom was gout. Because what's leukemia? Elevation in what? White blood cells. They're going to die. They have to, all that DNA has to then get recycled, and now all of a sudden they're producing way too much uric acid.
So that's the cancer link with it?
Yep.
Oh my
But too much
god.
uric acid is what kind of
That makes
causes
total
gout?
sense now.
What?
Are you saying that too high levels of uric acid is
Yeah.
what causes gout?
Yep. Did you ever see the commercials? They showed the guy, what was it? They showed the guy walking around with the big container, the big test tube with the green fluid in there. It was for the gout. What was the medication? I can't remember. You see it on the TV once in a while. It's because of uric acid levels.
wait, how is that connected to cancer?
Because in cancer, what do you produce?
White blood cell?
That's leukemia. But in any cancer, you're going to produce cells. Those cells are going to die, plus they're killing other cells. So something's got to get done with all that DNA, because when those cells die, that DNA is released into the body.
So because chicken's a protein, that doesn't, it's different, right? Like from red meat, like,
Right,
The way
it's
it
not,
works
it doesn't
out.
have as
Okay.
much,
that makes total sense.
Doesn't have as much muscle as cows.
what?
The chickens don't have as much muscle as cows, is that it?
They do, but they don't have as many nuclei. It's not as nuclei dense. Because it doesn't have as much myoglobin and all of that stuff. So any condition you get down to, gang, it gets down to the metabolism of it.
Food science.
What's
And
that leave you
then
to eat?
that I did in my food science class.
What?
What's that leave you to eat?
Pretzels. Coffee and pretzels, the absolute perfect diet.
That is actually, that's what I had today, coffee and pretzels. Why?
Did you really?
Yes.
You
I love
white
pretzels.
flour in
I
the
had
pretzels.
coffee.
Yeah, got white flowers out in the field. So uric acid is coming from the DNA. And when cells in our body die and we replace them, that's called turnover. So a high elevation of uric acid could indicate a high cell turnover, which you would see for leukemias. That's where that connection. You could also get high uric acid levels if you're dehydrated because you're not getting rid of it enough. If your body has to retain water, it retains waste products too.
What about the link where they say like if you're obese or overweight and you're eating too much red meats and fats, is there a
You're
link there?
dehydrated.
But-
You have less lean tissue.
But where's the cancer link in there?
Or
For like,
the
they
red
say if you
meats.
eat the red fatty goat meat, they say it's actually a link between
It depends.
obesity. Oh.
Give me 2 minutes here. The link there is how you prepare them. Some of the red meats, if you char them, the charring them winds up, causes some of the proteins to
include, like,
undergo
grilling?
carcinogenic changes.
Like a grill outside.
Yeah.
Wow.
Yeah.
They don't burn the meat.
That's why they say.
That's why they say don't char the meat.
Very interesting.
It all boils down to metabolism. See, don't you want to take a biochemistry?
I do now. Only if
No,
there's
I
no
still
math.
I still don't.
If there's math, I don't.
No, I'm learning more about friggin' food science in this damn class than I did in my food science
You're
class.
what?
I'm not here right now.
I am.
I'm not paying
I know,
I didn't
Oh
learn
my God, that's so
crap in my
interesting.
food science class. I'm kind of pissed because I felt like it was a glorified cooking class. I hated it. But I didn't learn shit.
Well, when he puts it up there like
Are you
that,
taking
I'm
that
like,
in the
what?
fall?
Probably.
I'm taking
Well, they
it
didn't
next
have a
spring.
proper
taking it
teacher,
this
one.
Marcy's taking it right now.
Two, we didn't have any of the instruments
no,
to
I think
actually
I'm
test
not.
density and
I was gonna say, how many science classes?
and like air, like
No, I
when you're
don't think she
baking, how the
got it.
airflow. You're supposed to have all these little things, and we didn't have any of them. I'm like,
Friday, Saturday,
and I was
Sunday.
pissed. I'm like, I cook for a living. I don't want to cook anymore.
You were more or less doing that.
Yeah, and then I got to take a food service operations 1 and 2 class in the fall and in the spring. I'm thinking, what do I do for a living? I do food service operations.
You should be a pro at it.
Yeah, but
else
it's,
do you have
I
to
hate
do?
wasting my money.
Like, did you have to start?
But
with
I have
from
to
the
take
ground
the
up?
class at least. I'm seeing if I can get out of actually taking the lab.
Oh, because of what you do for a living. That would be good.
Because
Oh,
I do it.
Micro-mic,
I mean, I've cooked for over 200 people, one place, and
Yeah.
I'm just done. That's why I'm going back to school.
Right.
I'm sick of getting
Yeah.
shit like this.
Old nagging people.
I'm working with drunks and alcohol, or drug addicts.
This is
now.
also a waste product. So a
they're
lot of
actually
times, we can get an idea of what's going on in the kidney when we measure BUN,
My gout.
blood urea nitrogen, and creatinine levels. So a lot of times you'll ask, what's the BUN and creatinine? They have to be in a certain ratio and stuff like that. Creatinine comes from creatine. Who remembers that?
Isn't that the stuff our nails and hair?
That's keratin.
Close.
Yeah, why?
Where's my chair?
Are you stuck?
I hate these chairs.
I have to like sit on the floor.
Muscle, right?
Muscle.
Oh, it's that stuff that the muscle, I remember.
I don't.
Muscle milk. That shit's nasty, by the way. Don't drink it. Chemical respiration.
Okay, so
God,
in
I
order
have
to
to see
make
that.
ATP, we can do it by three
We're gonna hit
means.
him so hard that his kids are
We
gonna be
can do it
hunchback.
directly with the mitochondria, that's using oxygen, that's aerobic. We can use glycolysis, which is where we use glucose, we break it up, and we can get a couple of ATPs that way. Or, for any ATP we utilize, when we use an ATP or break it down, it gives us ADP plus phosphate. If I can reattach, or I take a chemical that has a phosphate and transfer it to ADP, what will I have reformed? ATP. So we have a chemical called creatine phosphate, which will transfer its phosphate to ADP. When that occurs, the chemical left over is creatinine. Anybody remember what the name of this system was? Chapter 10 in A&P 1? Yeah. It's anaerobic. This is called the phosphagen system. So this is how we can quickly produce ATP in milliseconds. Just transfer phosphate from one creatine to an ADP. So the more creatine you have in your muscles, the stronger the contraction, because you have more ATP to engage more actin and myosin.
It's all connected.
Mm-hmm.
I hate that.
Freaking hate that. So the creatinine now becomes a waste product. We have to get rid of it. And we get rid of it through the kidney. So ultimately, by the kidney getting rid of the ammonia, the urea, the uric acid, and the creatinine, it's preventing these metabolic wastes, and primarily the nitrogen that they have, from building up in the blood and becoming toxic. When someone goes into renal failure, that's what gets them, the azotemia going into uremia. So when your kidney can't do it, you have to be put on dialysis. The artificial machine will do it. Now, at the same time, the question. I didn't even put a pathway up. And everyone just seems like you beat up all of a sudden.
We are.
It's the end of the semester.
My brain quit functioning an hour ago.
But gang, these four chemicals you're going to hear all the time.
I need some more carbs.
So, to me, yeah, we can measure them in the artificial urine.
You won't.
Fun. But doesn't it make more sense to know where they come from?
So where, like, on a regular basis would you get the creatine phosphate from?
Your body will make it. We'll take amino acids and create creatine out of it, and just attach phosphates. And we have enzymes that, it's called CPK, creatine phosphokinase.
So are you saying that these basically come from proteins?
Well, our cells will make it. Will make it. I don't know how much creatine actually gets into the body through creatine. Because the stomach is going to break it down, I would imagine, into something else. But hey, food bias, be careful.
Some acid.
What?
I'm saying if we fail this quiz, we will still pass.
Kidney stones.
Pretty much, yeah.
Now, in order for the kidney to do what it has to do, not only does it have to get rid of these metabolic wastes, basically as fast as we produce them. That's the downside of the kidney. The kidney only works as fast as we can get rid of the stuff. So technically, the kidney's always behind the 8 ball. Because to produce a waste product, you produce it first, get rid of it second. So the kidneys never 100% get rid of the waste products. It just gets rid of them at a rate that they don't reach toxic levels. As soon as they slow down, they're going to build up because your muscles are going to produce them, your other cells of the body are going to keep depositing the waste products into the blood. So that's why when your kidneys fail, you basically have 2 garbage men to clean the entire state of Ohio. The kidneys are trying to get rid of all the waste products that all the other cells produce, because the kidneys have direct access to the outside world through the bladder and everything.
They did a radio contest where they had people race to drink gallons of milk. And then the one woman died.
Oh, that was the we.
I think that was water.
The we. That was the play on words.
Yeah, you had to drink as much as you could and not.
And not pee.
Yeah. Oh, is that
So
what
we.
it is? So it overwhelms
you
the
didn't.
system?
So you didn't we.
Right.
Yeah, and she died. She overhydrated.
Overhydration. Okay, I thought maybe it was something to do with
No,
it.
she overhydrated.
Does it
When
cause,
you
like,
overhydrate, you will dilute all of your body fluids.
Makes sense.
I
You'll
thought
die
it was
very
something
quickly.
related.
Rebecca
Does
Bush
it
is the
cause
only
like
one.
once your cells rupture?
Yeah.
Yep,
Taking in too much water?
yep. Screws up the water balance, the osmosis.
So you're like drowning yourself.
Yeah, so what'll happen is you'll start to third space your fluid. So your body starts storing it in areas where it doesn't normally put fluid. So lungs, abdomen, the abdominal cavity, thorax. That's called third spacing your fluids.
My body couldn't even hold you. Straight through my veins.
Now, at the same time, we
Right?
have to get rid of these waste products. Any of the stuff we need, we have to be able to keep. It wouldn't make sense to go through your house and get rid of the garbage, but at the same time, you're getting rid of, cars, seats, furniture. Yeah, but I have to get rid of them because of the garbage. So there's almost a sorting or a filtering process that the kidney does in order to accomplish this. So the kidney, in order to still get rid of the waste products, has to be able to carry out three basic processes. The first process, which is a sorting or a filtering process, is called just that, glomerular filtration. And of the processes, this is the most important. Glomerular filtration, by definition, is the filtering process carried out by the nephron. We have a specialized set of blood vessels in the nephron that's called the glomerulus. They're capillaries. So how this works, when we send blood through the capillaries, the pressure inside the capillaries forces the liquid containing the waste products out, and it's going to keep inside the capillaries the red blood cells, white blood cells, platelets, because they're cells. I don't want to lose those. It's going to keep your clotting proteins and stuff in there. So what it does, it filters out the waste products, but keeps all the good stuff behind. So it's like a sorting process. So through glomerular filtration, this is how we get rid of the waste product. As soon as it's through that glomerulus, it's out of the blood.
What is the name of the process of all three together? You said there was three processes, so what's the name?
Urine production.
Oh.
So if I was a urologist, I would have in the phone book, for your information on your information, call.
Wow.
That's a good one.
We filter our blood, our entire volume, every 15 to 20 minutes. And every time we filter it, we remove a percentage of all those waste products. So roughly 3 to 4 times an hour, we're cleaning our blood of those waste products. That's massive.
Does it take 15 minutes to filter out?
Anything that slows that down means those waste products are in the blood a lot longer. Now, even though we filtered out, we have forced out the waste products through the glomerulus, okay, and what happens is there, as the blood comes in, it forces the fluid which contains the waste products out. That fluid gets picked up in the nephron. This area here is kind of like a collecting area. This is called Bowman's capsule, and then we'll send it through the nephron. Even though we've just gotten rid of a good amount of waste products, we didn't get rid of all of them because the blood's moving through the capillary, so not all of the blood got filtered. That's why it takes 15 minutes to do the entire volume. But we're also losing potentially some water, some amino acids, some valuable stuff. So in order to prevent that from showing up in the urine, we have to carry out another process which is called tubular reabsorption. Should we find glucose in a normal urine sample?
Yes.
No.
No?
No, you shouldn't find sugar in a normal urine
Find it in
sample.
your blood.
So what happens, any glucose that got through that filter, the nephron will return it back to the bloodstream.
So what gives urine its sweeter smell? Like, no, I'm saying, like if a person has a sweeter smell to their urine.
This know my pee.
Like I've had a lot of clients who aren't diabetics or anything, but their
Are they
urine-
hyperglycemic?
No. But their urine always has like a sweet. No.
There should not be in there.
I didn't eat asparagus.
I did not know that.
Nope. We 100% reabsorb all the sugar that gets filtered out. So if you start finding sugar on a urine sample, they're going to start testing for diabetes. Should you find proteins in a urine sample?
Yeah. Oh, low.
No.
No.
No?
That's because any proteins that get through that filter will reabsorb them.
Oh.
What if they aren't?
What if they are? Then you got to figure out why. Now, if you were pregnant, can that cause a protein to be in the urine? Yes. So, and that's a normal because your blood pressure is higher, you've got all this other stuff going on. But you can't let it get too hot. Does anybody know what that's called when they start finding protein, large amounts of protein in the urine if someone is pregnant? Toxemia pregnancy. So preeclampsia, eclampsia.
So can it be from dehydration?
It could be from dehydration too, yeah. But notice, it's indicating that something's not right.
Yeah.
So the tubular reabsorption is the protein and the glucose.
The glucose.
Or back in the blood.
Yeah, any clotting proteins will reabsorb.
The
Any, if we're low in sodium, we'll reabsorb it. Low in calcium, reabsorb it. Anything we need and we're low in, we'll reabsorb it.
Whether we need it or we have too much, it balances it out.
If it's too much, we won't reabsorb it.
It'll go out.
If we have too much sodium in the blood, see, this is the beauty of the nephron, it can tell. If there's too much sodium in the blood, the nephron will say, well, we got plenty of sodium, I'll let the excess just flow out to the urine. This is how the kidney is able to adjust whether you've taken in too much or not enough. The kidney will attempt to balance it out.
That's amazing.
So where?
It is, it absolutely is. When you think of what the kidney does, there's nothing else. That's why when this fails, there's not a whole lot they can do for you, except give you a new kidney if you're a candidate. Julie.
So, I'm just confused. So if they say not to eat a lot of sodium, even though the kidney's able to flush it all out, where's the?
Because while it's there,
Blood pressure.
I mean, you're not going to flush it all out in one shot. It's going to take a
Because it
while.
never fully empties.
You never, yeah, so.
Well, because you're constantly filtering, aren't you?
You never stop filtering. We filter at a rate of 125 milliliters per minute, 60 minutes in an hour, 24 hours a day. Any less than that, your waste products will build up in your body.
So I have a question. My patients who are usually on dialysis, a lot of them don't create any urine.
So they're in your,
Without
yeah, because their kidneys are dead,
So even with the filtration from the machine, they don't create anything.
right?
Yeah, so what's the timeline for that?
take them off that machine and they'll die. They're and urine. The kidneys are dead.
Don't
You
trip
can only
over the
make
plug.
urine if you have kidneys.
Is that a higher stage?
I'm such a
Oh, that's
bitch.
advanced, yeah, that's advanced. Anyone want to know the number one reason for being on dialysis? Number one reason for your kidneys to fail?
Alcohol.
Diabetes. Number
That's the
two,
liver, never mind.
blood pressure. Diabetes and high blood pressure. And they usually go together.
82% of all people who get put on transplant list are waiting
Yep.
Or what?
for kidney.
My cousin is, he was waiting for his second transplant. When he was 10 years old, he had one.
Yep.
It lasted 20 years.
Yeah,
and now
that's
he's
about
getting
it.
We're about to be able to grow them though, 3 prunings.
Yeah, I'll wait on that.
They've already grown a bladder and things like that.
What about
Okay.
this dude getting a head
Yeah,
transplant?
yeah, okay.
You're bleeding out.
I'm sure at some point, but how is that going to organize? You can make tissues, but you have to have a scaffolding. You have to have the connective tissues, and you can't do that. Without the connective tissues, the normal cells of that organ don't work.
Everybody else hears that.
So I would imagine they're going to put those into our body, and our body's just going to attack it and kill it. Now, the third process is called tubular secretion. Tubular secretion primarily is a way that we get rid of excess acids. It's a way to maintain pH. And I'll kind of go over that a little bit more next week. So what the nephron does to produce urine, get rid of the waste products and do all the other things I said, the nephron carries out those 3 steps. Glomerular filtration, tubular reabsorption, tubular secretion. Any screw up of any one of those steps and you're going to have an abnormal urine sample. And I gave them to you in the order of importance. Filtration is the most important. A close second is reabsorption. And then a distant third is secretion.
So urine production through nephrons.
Now, in the course of one day, we send through, and here gives an idea of just how important reabsorption is. We send through, in the course of one day, through our kidneys, 180 liters of fluid. How many do we urinate out on average? 2.
That's it?
That's it.
Wow. Even if you're not a diuretic?
Yeah, well, diuretic, you'll increase that.
Oh.
Okay, but under normal circumstances, we send through 180 and we only urinate out 2.
Wow.
So that reabsorption prevents us from dehydrating, while at the same time preventing us from losing clotting proteins and everything else. That's why I say when you think about what the kidneys do, it's absolutely amazing what they do. Very quietly working behind the scenes. It's not as glamorous as respiration or pumping blood or anything like that, but
That's crazy.
yeah.
Have you ever heard of sitting on cold concrete and they always say it's not good for your kidneys? I just remember my mom always saying that. Don't sit on the concrete.
I thought it was because it caused hemorrhoids.
I thought she said the kidneys.
I never knew the name I was putting on cold concrete.
I don't
I
know.
could have sworn she
Give you I heard it gave you a flat
old wives'
butt.
tales. So it's just an old wives' tale.
Don't listen to old wives' tales.
Just because it's your birthday.
I don't have one.
I know. I want to get the hell out. Thank you.
Oh, you're born in April too?
All right. Here is a chart that's showing us a typical normal urine sample. Okay. So you'll see that we do get out some stuff, we don't keep everything. We do get rid of some sodium and chloride, potassium, that's why we have to replace that through the diet. Notice we do get rid of ammonia. If we come down here, look at the waste products that we get rid of. Look at the amount of urea that we get rid of a day. 21 grams, almost an ounce of urea a day. That's huge. Okay, creatinine, almost 2 grams. Uric acid, a half a gram. Okay, bilirubin. That's and urobilin, that's the breakdown from the red blood cells. We have to get rid of that because it's water soluble through the kidneys. If we don't, that can backtrack up and then lead to things like jaundice. Other chemicals that we see in here, small amount of amino acids, very, very little. Here's a big one, ketones. That's probably why your patients, it's the
Yeah.
keto acids.
Okay.
So they might be
Keto
digesting a lot of fats. Okay, ketones or keto acids, those are what diabetics have to be careful of. If they don't take their insulin, they can't use sugar for energy, so they switch over to fats.
Could it be too that they just, older people eat sweeter foods
It-
more often? Could that be it?
But they're not gonna
Even
have-
if they're not, okay. I'm just
Okay, so
guessing.
if you're urine, like, what I'm trying, I don't know how to put it. You eat a ton of like sweet potatoes and carrots and your skin will turn orange.
That's because of the vitamin A.
Yeah,
Hypervitamin O is because it's fat soluble.
Okay, so it
So it gets in
doesn't
your
come out
tissues.
as easy as others.
Yeah, so you're relying on the liver to get rid of those primarily.
Okay,
Unless we can convert them into a water soluble substance, and then the kidney will get rid of it.
okay.
But a lot of times it relies on the liver to do the conversion. Thank you. So there is a process, okay, where we can do that. Glucuronic acid and attach it, and we can convert it to something water soluble. If your liver can't do that, then you're going to have problems. But in the case of diabetics, if they don't take their insulin, we can't get the sugar into the cells. If the sugar doesn't get into the cells, it can't get to the mitochondria to produce ATP. So that's why their blood sugar goes up. So what they're going to do, the cells will start now digesting fats that are in there. And when you digest fats, you produce large amounts of ketones. So individuals that go onto a starvation diet, remember what was it, the Atkins diet? Was that it?
Low
The
carb.
low carbs, high protein, basically by knocking out the carbs, you're sending them into diabetes. So now their body's going to shift over to burning fat, which is what they want because they want to get rid of the weight. But you're going to produce ketones because it's burning fats is not nearly as clean as burning carbohydrate. Ketones are a large waste product and they're acidic. We have 3 ketones that we got to get rid of. Acetone, nail polish remover, our tissues make that. Acetic acid, vinegar, so that's where you get that smell from. And then acetoacetic acid and hydroxybutyric acid. Those are your ketones. And they'll kill you.
I'm just wondering, why do they tell you then to drink vinegar?
Apple cider vinegar
Yeah,
with the mother,
yeah.
yeah. Bragg.
Because that's going to get neutralized in the blood. And they're
And you'll
not going to
just get
tell
rid of it
people
anyway.
that have kidney problems to drink vinegar.
Okay. Just
So
a Dr.
Atkins
Phil.
bad, huh?
Oh, Atkins is horrible.
If you read the old literature on Atkins, you were only supposed to be on it for 2 weeks and then off for like 2 months. And then on it again for 2 weeks and off for 2 months. But the kooks, I'm going to be on for life!
There's RNs in my facility that are on that. They've
Oh,
been on
yeah.
it for a while.
Well, they now have what's called a modified Atkins, where now basically you go to this company and you buy their foodstuffs and everything is basically low carbs. It has enough, it basically has the daily allowance of carbs. So basically what you're going on is a normal, balanced diet.
My dad's doctor put him on a low-carb diet because he wants him to lose weight.
Well, yeah, because that, we're gonna use that very quickly, and whatever we don't use, we store.
It's temporary though, probably.
Well,
So, and you'll lose weight faster that way.
yeah, well, probably because it's hard, it's more important for him to lose the weight.
Does he have any respiratory condition?
He's got congestive heart failure, but that's not really.
If that's affecting lung function, if you're taking carbs, you produce a lot of CO2. So a lot of times they'll tell them, put them on a low carb, so it reduces CO2 levels that they produce, so it's easier to breathe.
So that would be easier for my uncle who has
COPD, yeah, exactly.
Huh, okay.
Yeah, but you also gotta watch your carbs because your body does need carbs to
Right,
function.
you do need
Well, my
carbs,
dad sneaks
but
in
it's
it.
the balance, it's, again, you're running the balance. You're running the balance, okay? When you have a disease, things aren't in balance, so it's a chess game. I'm gonna fix here, but then that's gonna cause the dike to leak over here. So you plug that up, but then that's gonna cause a leak over here. So you're constantly running back and forth. As soon as you're out of homeostasis, you got a problem.
Yeah.
If you can't correct it yourself, well, now you got a disorder. And the kidneys are what we call an end organ. There's nothing else in the body that does what the kidneys do. The lungs and stuff, you'll see next week, they'll try and work with the kidneys to balance out the acid levels, but they can't get rid of the metabolic waste and stuff.
The liver doesn't even take over?
The liver's job primarily is to, because the liver doesn't have direct access to the outside world. It has to do it through the gallbladder, which then puts it into the intestine, and hopefully you'll get rid of it. But the liver's job is mainly to get rid of the fat-soluble waste, puts it into the bile. Any water-soluble, the kidney will convert something fat-soluble to water-soluble, and then it relies on the kidney to get rid of it. The liver can't. So you're around because, well, everything's working, but you can see what happens when the kidneys don't. Everything that winds up helping us when we're healthy turns around and now it works against us because the kidneys are no longer in part of the control.
Is there anything you can do to prolong the better kidney function as you get older?
Yeah, don't do anything that would affect them. So limit the amount of medications you take, make sure you stay hydrated. Every time you take an aspirin, it's going to kill a nephron. It's going to affect it. Everything is nephrotoxic.
How many nephrons die a day?
How many nephrons die a day? A couple, probably.
Can you rejuvenate them? No? Okay.
The liver regenerates itself, though, doesn't it?
To a degree.
I had to go to the Montefiore Hospital in Pittsburgh for my mother-in-law because when the statin medicines affected her liver, and when you walk through there, I mean, there's residents there with patients there with their yellow eye whites,
Mm-hmm.
and their skin is all yellow.
Yep.
It was a liver floor. It was just weird.
Yep,
to see.
statins. They're not benign.
She was affected by that, yeah.
Yeah, they usually have to do liver tests on those people to monitor them.
Yeah, she waited and waited, and her eye whites were yellow, and she
Yep.
finally went, and they sent her right downtown.
Yeah, because the way the statins work is that they prevent your liver from producing the cholesterol.
I remember you saying that. It's
Yeah.
like, because your body needs, your heart needs the cholesterol.
Mm-hmm. You want to have a clean liver? Be a clean liver. All right, any questions on that, gang? You're out of here.
Thank you.
Oh, your shoes are cute.
Thank you. Sit down.